Scientifically speaking, every problem has a solution. There may only be delay in finding it. This is a trigonometric equation which looks abnormal. It is abnormal in the sense that it is equated to 5. We know that the sine function has its range of values from -1 to +1, and this is true when the domain of sine x is the real number set. Sine x equals 5. Obviously, 5 is not within the range given above. Don't forget that we have two types of numbers: the real numbers and the complex numbers. Every number is either a real number or a complex number. If a number is not real, then it is a complex number. Since 5 does not fall in the range which will give the real number, then x is a complex number. So, we can infer that x is a complex number. Since x is a complex number, write it in the form of 𝗧 plus 𝗧𝗏𝗧. Now, instead of writing sine x, we write sine 𝗧 plus 𝗧𝗏 equals 5. The goal now is to find the values of 𝗧 and b. Let us start by expanding sine 𝗧 plus 𝗧𝗏. We know that sine 𝗧 plus b is equal to sine 𝗧 cos b, plus cos 𝗧 sine b. This implies that sine 𝗧 plus 𝗧𝗏 is equal to sine 𝗧 cos 𝗧𝗏, plus cos 𝗧 sine 𝗧𝗏. There is something we still need to do in order to isolate the imaginary number. We need to break the bond tying it down. This can be achieved by using the close relationship between the trigonometric and the hyperbolic functions. Sin bi is equal to I sin b, while cos bi is equal to cos b. So, by replacing this identities we have a new expression. Sin 𝗧 plus bi equals sin 𝗧 cos b plus I cos 𝗧 sin b, which is equal to 5. With this expression, the problem is half solved. To balance the right-hand side with the left-hand side, add 0i to the right-hand side, and this becomes sin 𝗧 cos b plus I cos 𝗧 sin b equals 5 plus 0i. Now, we can easily identify the real part and the imaginary part of the expression. The real parts are denoted by RE, while the imaginary parts are denoted by IM. We now have to equate the real parts since they are equal, and to equate the imaginary parts since they are also equal. This gives two equations. Sin 𝗧 cos b equals 5, and cos 𝗧 sin b equals 0. The problem has now reduced to a simultaneous equation. Let's solve this beautiful equation on a new page. What we want to do now is to solve this simultaneous equation, with equations 1 and 2 respectively. Let us attack the question from the second equation, cos 𝗧 sin b equals 0. By dividing both sides by sin b, cos 𝗧 equals 0. If cos 𝗧 is equal to 0, then 𝗧 is the cos inverse of 0, which is pi over 2. This implies that 𝗧 is equal to pi over 2. To calculate the value of b, let us substitute pi over 2 with 𝗧 in equation 1. We now have sin pi over 2 cos b equals 5, which simplifies to cos b equals 5, and b equals the cos inverse of 5. Now, 𝗧 is equal to pi over 2, and b equals the cos inverse of 5. Don't forget how we started. X is equal to 𝗧 plus bi. Let us put in the values of 𝗧 and b to get the value of x. X equals pi over 2 plus I cos inverse of 5, but because the sine function has a periodicity of 2 pi, we add 2 pi k to x, and have it in mind that k can take all integer values. Finally, x equals pi over 2 plus I cos inverse of 5 plus 2 pi k.